Hi, welcome to the 8th week of Consider This, Simplifying the COVID-19 Conversation. I, my co-host Heidi Budinger, have been so happy to join you this semester talking about COVID-19. This week we're going to be talking about testing for COVID-19 with Liz Ruley from the University of Notre Dame and Paul Hergenrother from the University of Illinois. So I thought in this tutorial I'd give you an overview of the types of tests that are available. And I have other tutorials posted that talk about each test in detail. So what kind of tests do we have for COVID-19 testing? So first of all, we're not really testing for COVID-19 because COVID-19 is the disease. We're testing for the virus. So really it should be SARS-CoV-2 testing. There are two types of tests, diagnostic and serological. Diagnostic tests tell you if you're currently infected, and serological tests tell you if you've had a past infection. There's two types of diagnostic tests, molecular and antigen, and you may have heard the molecular test referred to as PCR, or polymerase chain reaction, viral RNA test, or nucleic acid test. Now, I posted a previous tutorial in the wastewater session about PCR, and it's the same test of whether or not you're testing a saliva sample or a nasal swab sample as it is for wastewater. So I've reposted that in this session. So for the molecular testing, what we're looking for is the viral RNA, or the genetic material that encodes everything for the virus. For the antigen testing, we're actually testing for the proteins that are made by the virus. And most antigen tests test for the nucleocapsid protein. And the reason for this is because it's just overexpressed more so than other proteins like the spike protein. So for molecular testing, you can, as I mentioned, test all sorts of samples. But usually when you're doing a diagnostic test, you take a nasal or throat swab, or as we'll be talking about a lot this week, saliva sampling. Usually you get those results back in 24 to 48 hours. But with the uptick in cases lately, that's being delayed by some laboratories, as well as long lines to be tested. Usually there are a lot of low levels of false negatives for the molecular tests. So that means if you get a negative result, you can be pretty confident that you're negative. Although the rates that are published for different tests, there's like 170 to 200 different molecular tests out there. Those rate of false negativity, it ranges, and that can be for a variety of reasons. The test might not be very good. Could be the laboratory capacity needs improved, or the sample wasn't taken correctly or stored incorrectly. There are false positives with molecular tests. They're low false positive rates, but you sometimes get false positives. And so in some laboratories, if they get a positive test, they'll test it again to make sure that it's actually positive. So antigen testing is usually done with nasal or throat swabs. The tests are not really sensitive enough right now to use antigen testing with saliva. The good thing about an antigen test is it comes back quickly, 15 minutes, so that you know pretty quickly if you're negative or positive. The problem is there's a high false negative rate, usually not over 50%. That wouldn't be a good test at all, but some of them range around 30% false negative. And that's usually compared to testing the same sample by PCR. And so you can't always be sure that you're negative if you get a negative antigen test. But if you get a positive one, you can be pretty confident that you're infected. Serological testing requires a blood sample, and it's testing for antibodies in your blood of the class IgM or IgG, and I'll talk about that a little bit more. So if you remember our timeline of SARS-CoV infection, you get exposed, the virus replicates, and eventually gets removed by your immune system. And it's usually 5 to 7 days before you're symptomatic. And the infectious stage is a little bit before you're symptomatic and wanes by the end of your symptoms. And so the different kinds of tests really test different places in this life cycle. So the first thing is usually after exposure, you're recommended not to be tested for 3 or 4 days after exposure. And that's because the viral load has not gotten high enough that the tests can detect them. And usually that's done by PCR. PCR, however, can continue to detect viral RNA long after the infectious stage, and even when you probably don't have any active virus in your body, and just the RNA is hanging out in the body in that way. Usually the antigen tests, you can be pretty confident that if you're positive that you're infectious. So this can be actually a really good tool. So if you remember or watched the PCR tutorial previously, there's this term CT value or cycle threshold. And that's because polymerase chain reaction goes through a cycle of different temperature gradients and measuring the viral RNA. And so what happens is eventually the number of copies that are amplified gets over some threshold, a background level threshold. And that's what we call the CT value. And so this example, our CT value is 20. In this blue sample, the CT value is 21. And because each cycle, there's a doubling of the viral RNA, you can assume that the sample in green has twice the amount of virus as the sample in blue. You can have different CT values, this one here at 35, and some that never reach the background. And usually what we say is those over here past 35 are really a negative result probably, and those below 35 are positive. So I looked at this study that was posted in bioRxives or medRxives, and actually what they did is they developed a tool, a simulation tool where communities or individuals can try to determine what is the best testing strategy for them. And I have posted that in the additional resources. But they also did some other testing, and that's this table here. And so they measured the actual RNA copy number of viral RNA and determined that less than 1,000 copies around cycle 39 is what equates to cycle 39. And that's really not enough copies to be infectious. Above 1,000 copies, or right about 1,000 copies would be at cycle 36. And at 4,000 copies is about cycle 34. And so even at cycle 34 is where you can start saying that you're in the positive range of infectiousness. Rapid antigen tests can detect 50,000 copies, and we really think you're infectious at 3 million copies, and that would be at about cycle 24. So now I want to talk a little bit about serological testing. And so if you look at our life cycle, if you remember previously, I talked about innate and adaptive immunity. And so your innate immune response, or the first line of defense, happens early in infection. And it's not till much later that you get your adaptive immune response. And your adaptive immune response involves T cells, but also antibodies. And if you remember, we have different kinds or classes of antibodies: IgM, IgG, IgA, IgE. IgA is really important in your mucosal surfaces. So like in your nose, for example, it gets secreted to fight off virus. But when we generally talk about antibody testing, we're testing for IgM or IgG because it's in the blood. And really the first antibodies to come up are IgM, and that's pretty late in the infection. And it's really not until much later, around 2 weeks, that you have appreciable levels of IgG that you can actually remember or measure. And so that's why when you do serological testing, it's only testing if you've been exposed at some particular time. Some other terms that we might be talking about will be pooled sampling, and we'll talk about that in particular for saliva testing. And that's where you take samples from many different individuals, pool them in once and test them. If that pool is negative, then everyone is negative. If the pool is positive, then we have to test each one of those individuals. Now, pooled sampling is only really effective or worthwhile doing if the rate of infection in the population is low. Because if it's high, then all of your pools will be positive and you'll have to test everybody individual anyway. We also will be talking about POC, or point of care tests, and that's tests that, like an antigen test, for example, that the physician's office could test right away and give you an answer. And we will also be talking about CLIA, which is really a regulatory term that labs have to go to give diagnostic tests. So anyway, thanks for joining us. I'm looking forward to it.